Okay, as I mentioned just now, if I want to differentiate logarithmic term, it's also very simple. You just have to follow this type of rule. First thing, if you want to differentiate logarithmic term, check out what is the bracket term. So in this case, you can see ln of fx, the bracket term is fx. Put it at the denominator. After that, differentiate the denominator, put your answer on top as a numerator, and then that's it. We are done. Okay, don't believe? Look at the next one. What is the bracket term inside here? Is it ax plus b? Straight away put it at the denominator. After that, differentiate ax plus b, what do we get? A, right? There. You will see at the numerator, and we are done. So it's quite similar to exponential, the step. Just copy the original bracket term at the denominator. Differentiate the denominator and put your answer at the numerator. So if I want to do part B, alright, we only know how to differentiate dy dx, but apparently in part B, y is not the subject. And you see a stupid e down there. What do you think we should do? Introduce logarithm. Okay, how to introduce? Ln. Okay, so I'm going to show it now. This is the original question. But I want to make y the subject. So, because e is there, I don't introduce log. I introduce natural logarithm, which is your ln. So, I'll introduce ln on both sides. Can you recall in logarithm, we can do something to the power? Bring it down in front. Oh, but take note. What is ln e? Ln e is the same as log e to base e, and this will give us 1. Okay? So actually, even if you bring y in front, ln e, eventually you will still get 1. So y is equal to ln of sine 4x. Okay? Now, are we ready to continue? We can still do our dy dx now. So, what is our bracket term for the ln term? Sine 4x. Where should we put it? Denominator. Now be very careful. We are differentiating the sine 4x. Differentiate sine, we will get. Differentiate sine, we will get. Cosine of what? 4x. Is this good enough? No, you need to differentiate the angle. What is the angle here? So differentiate 4x, we will get 4. Okay, this answer is good enough. But sometimes they want you to simplify it. Can you all recall what is cosine over sine? It's cotangent. So even if you give me 4, cotangent 4x, okay, this is also good enough. It's not a must. Alright? Okay, like what I emphasized on the whiteboard, the most important thing is always to simplify. Don't use very complicated way to do differentiation for logarithmic terms. So simplify. Cube root can be written as power 1/3. What can we do to the power? You can bring it down in front as a constant value. Oh, it looks like normal differentiation already. Okay, I don't want any power term at the bracket. I don't want any bracket times bracket, bracket divided by bracket. So long it looks like a normal logarithmic term, we are ready to differentiate after you simplify. So, now that I want to find the first derivative, the 1/3, don't worry, just write the 1/3 is a number. What is the bracket term? X cubed plus 2x. Where should we write it? At the denominator. Then we differentiate the denominator. Am I right? What will we get? okay, this answer is good enough. This answer is good enough. But some of you will say, teacher, I don't like the bracket over there. Then what can you do? Don't make this mistake. Remember, numerator times numerator. Denominator times denominator. Alright? So if you really want to, you can still write like that if you want to, but it's not necessary. Okay? Both answers are acceptable. Then you ask me, teacher, can I multiply the 3 inside to get 3x cubed plus 6x at the denominator? You may. Again, not compulsory. Can?